All right, so let's start off by looking at number 16, which gives you copper 1 plus sulfate. And you've correctly named it copper 1 sulfate. Now the charge on this is a plus 1, and the charge on the sulfate is a minus 2. And I want to make it so these are equal. Because if the charges are equal, then the compounded form won't have a charge, which is what is generally the case for a compound. And so I say, well, how many of these copper ions do I need to balance out the charge of these sulfate ions? So I have one positive per copper ion and two negatives per sulfate ion. So I choose the lowest common multiple. So I say there's a plus 1 here. If I have two of those, that will equal my minus 2 here. I have a plus 2 and a minus 2. At least they'll cancel each other out. I guess they won't explicitly be equal, so ignore that. So in other words, I can write the formula Cu2SO4. And this doesn't have a charge because the two copper ions together cancel out the 1 minus 2. So that works the same way. For instance, number 24, where you have magnesium 2 and chlorate, or chlorite. No, 8, chlorate. All right, well, I have two magnesium charges here, but one chlorate ion. So this is like a plus 2, and this is like a minus 1. So I need two of these to equal one of these. In other words, I need MgClO3 2. The reason why I put these in parentheses is I don't just need like two oxygens or two chlorines. I need two of this whole ion. If I don't have this whole ion, I don't get the minus charge. That charge applies to everything. So just like in math, when I need you to do something to more than one variable at a time, I need parentheses to show me that I'm doing that. So let's look at 28 now. 28 gives you a similar problem where you have like barium plus a bisulfide or hydrogen sulfide. And I'm going to show you a trick. You can take the number, ignore the plus or the minus, and you can bring it down to the other ion. So like this one becomes barium, Ba. The HS has a minus 1 on it, so I would put a 1 here, but I don't need to write a 1 because it's implied. Hydrogen sulfide. I have two barium charges, so I take that 2 from the barium and I stick it down below. And again, I need the parentheses to delineate that HS is all one ion, that it's not just two different atoms bound together randomly, that it is the bisulfide ion, the HS minus. And so I write the answer out like this. And that would work for anything. Let's just say you have like tin 2 plus phosphate PO4 minus 3. Then I get like SN3 PO4 2. And if you don't see where that's coming from, this 2 came down here. This 3, again ignoring the charge, came down here. So those pluses and minuses don't matter. And that ends up being pretty similar to what you've been doing. Like on 39, where you have lead 2 chloride, the ion lead 2 is Pb plus 2 from your sheet, and chloride is Cl minus. So you, of course, just get a PbCl2. Where like number 43, iron 2 nitrite, is iron 2 Fe2 plus nitrate NO2 minus, or you get an FeNO2 2. Anyway, that should pretty much fill out your basic questions. And let me know if this doesn't help a lot. But in general, the rule is going to be this. If you have two ions, I don't care what they are, like looking at 35, Fe3 plus SO3 2 minus, what you're going to get is the first one, the cation, the anion, And you're going to take this number here and put it down, and this number here and put it down. So I get Fe2, parentheses, because I need all of this, 3. And there's my final answer. I hope that helps.